In a previous video, we looked at finding the slope of the tangent line to y equals x squared at the particular point 2, 4. In this video, we now want to go ahead and say, hey, what if we want to find the slope of the tangent line of that curve at just any old point? Not just specifically 2, 4, but at any value, for any value of x. So we would begin the same way, using our formula for the slope of the tangent line. Its limit as h goes to 0 of f of x plus h minus f of x all over h. And instead of plugging a 2 in for x this time and working it out, now we just leave x as a variable. Leave x as a variable, and we work through the problem the same way. So we plug x plus h into x squared. That'll give us x plus h squared. Looks like I'm getting way ahead of myself. Sorry, my cursor kind of got away from itself. I thought I had that paused. So limit as h goes to 0 of x plus h quantity squared minus x squared. Right. And then we evaluate x plus h squared by multiplying it out. X plus h times x plus h. And when we do, we'll get x squared plus 2xh plus h squared. And of course, x squared is just x squared all over h. And you might notice if you compare this back to the previous example where we had at x equals 2, that the 4's canceled out in that problem. And here you see the x squareds are going to cancel out. And then just like in the last problem now, there is a common factor of h remaining in the pieces that are left in the numerator. And so we can factor that out. Limit as h goes to 0 of h times 2x plus h. And then just like the 4's canceled out, just like the h is canceled out in that other problem, they'll cancel out here, leaving us with a limit that we can now just allow h to go to 0. H can now just go ahead and hop on over to 0, and we get just 2x. If you go back now to our problem when x is 2, we had a slope of 4. Well, if we plug 2 into that formula, we'll get 2 times 2 is 4. So this is consistent with that result. So this is going to change depending on what x is. In other words, the slope of the tangent line is a function of x. It depends upon x. We have a name for that function. We call this function the derivative of f of x. All right, so instead of talking now about a slope of tangent line function, we refer to it as the derivative. The notation for derivative is f followed by a little prime symbol. So f prime of x means the derivative of f. And so taking our slope of the tangent line formula, we can now define the derivative to be the limit as h goes to 0 of f of x plus h minus f of x all over h. So that is our formula for the derivative. And that's the formula we're going to be using here in the upcoming examples to compute some derivatives for our functions. But please remember that what it tells us is the slope of the tangent line at a particular point x, f of x on the graph of f of x.